So let's do a news vendor example. So a good example of when the news vendor makes a lot of sense is think about you run a store that sells different wetsuits, but it's only open during the spring selling season. And so for us to get those wetsuits, we have to forecast demand early on, like in October. And then it takes a couple months for our supplier to deliver this year's new wetsuits. And so you receive them in, let's say, end of January, and then you have the selling season. And then at the end of the summer, you close up your shop and you go on vacation for winter. And so you don't want any leftover inventory because you have all of that capital investment. And so you sell all of them at a discounted price. And so if you look back at your historical data and you create a forecast, you could think about creating a forecast for what is the forecast for the selling season. So I want to know, on average, how many do I think I would sell, and what's our standard deviation, and what does demand look like over that selling season. And so if we did that, for this example, we have that it's normally distributed with a mean of 3,192 suits, but quite a high standard deviation. So sometimes we sell a lot, sometimes we don't sell very many. And so the news vendor problem then asked to figure out, how many should I order? So given I need to place this order at the end of October, I don't sell until the spring, how many should I order? So as kind of a test your thought process, there's no right or wrong answer here, but think about this. Would you order a small number between 0 and 1,600 units? Would you order between 1,600 and 2,800? Between 28 and 3,192, which is the expected value? Between 3,192 and 4,000, or more than 4,000 units? What do you think? So again, I actually haven't given you enough information to tell you what's a smart decision here, but this is what the news vendor model is doing. It's saying, I have to place an order before demand materializes. I have a forecast for that demand, but I'm not exactly sure how many I should order. And what is the correct answer? The correct answer is we need more data. So we need to know the cost of underage and the cost of overage. So we need some economic data. And so if we think about some economic data, if this is what's happening, so we sell each suit for $190. So that's what a customer would pay us to buy a suit. But we buy these from our suppliers, again, before demand materializes, at $110 per suit. And so this economic information is useful, but it's not fully everything we have. We also, at the end of the season, need to discount them. And we discount them quite heavily so that we can get rid of them. And then when we start over again, we have all the new season's suits. And so at the end, we sell it for $90. You notice that's actually at a loss for us. But it's better than not getting anything. And this discounted sale price is what's called the salvage value. Okay? So this economic data is what we need to calculate the overage and underage costs. And once we have the overage and underage costs, we can then determine Q, or how many we should order. And why do they have the overage and underage cost is, well, you could say I ordered too much. So if I ordered too many and I had extra, I have to discount them. And every time I discount them, I lose money. However, if I order too few, I lose out on that potential for a sale. And so that provides me profit. And so there's this overage and underage cost we need to balance. And so let's quantify that for this example. And so remember, CO is the overage cost, and it's per unit. So if I had one extra wetsuit left over at the end of the season, how much would that cost me? And so for this example, I pay $110 in. At the end, I discount them to $90. So if I have one left over that I have to mark down, that costs me $20 per unit. So that's CO for this example. CU is the shortage or underage cost. Sometimes this is CS. This is the cost to us if I had one more wetsuit and I would have made that sale. How much would that have cost me? So I had one too few. So here the idea is that how much profit am I missing out on? So I buy things for $110, but I sell them for $190. So if I had one too few, I missed out on $80 of profit. And so for this example, CU is $80. So that's gathering this economic data. Now we need to calculate a critical value. And so here to test your knowledge, here's a reminder what the critical value ratio is. It's the cost of underage over the ratio of the cost of overage plus underage. And so for this example, what is O'Neill's critical ratio? Pause if you need to. So the correct answer here is C. So our cost of underage is $80. Our cost of overage is $20. And so if we do this critical ratio, we get 80%. And so C is the correct answer. So now we've done step 2 in how to figure out our Q star. And so our remaining step is to determine Q star. So as a reminder, we know our demand distribution during the selling period is normally distributed with a mean 3,192 and a standard deviation of 1181. We just calculated the critical ratio of 0.8. And so the next thing we need to do is, because we have normally distributed, we need to find the Z value. And so we go and look up on a normal table, where is 0.8? And if it's in between something, you should always round up. And so for this example, you would choose Z of 0.85. So that's our Z value. And now again, because we have normal distribution, we can use the Z statistic to convert it from the standard normal table, which is a mean of 0 and standard deviation of 1, to the normal distribution we have, which has a mean of 1392 and a standard deviation of 1181. And so for this example, we should order 4,196 wetsuits before the season. And if we do that, we will maximize expected profits. And so here the key is expected. If we do this over and over and over, assuming the selling period has the same normal distribution, we would expect to maximize that. However, again, demand is a random variable, so that doesn't mean in each selling period we will have the most. But if we do this over in time, we would maximize the expected value.